Hi friends, welcome back. Today we are talking about rectangles. Now, in a previous video, we talked about parallelograms. Parallelograms, let's get our quadrilateral chart here. Quadrilaterals, four-sided polygons, parallelograms are a type of quadrilateral. A rectangle is a type of parallelogram. So some parallelograms are rectangles, but not all parallelograms are rectangles. So remember those properties of parallelograms. Those are going to be important, and we talked about those in a previous video. Pause if you need to. Okay, so what's the big deal with rectangles? All right, some parallelograms are rectangles. Once you've decided a quadrilateral is a parallelogram, check to see if it's a rectangle. How will you know? Not only will it have all the properties of a parallelogram, which I just showed you, also the angles, it's going to have at least one right angle, because if you have one right angle, all those properties of that parallelogram, that means that they're all going to be right angles. So we're going to have 4 right angles total. The diagonals are also going to be congruent. So the properties of a rectangle, all those properties of a parallelogram, also one right angle, which makes 4 right angles, and those diagonals are congruent. And just a friendly reminder on that, that means that this guy right here, this whole thing, is going to be as congruent to this whole thing here. I've also marked this rectangle with those previous properties that we talked about. So you can see both sides are parallel, opposite sides are congruent, and like I said, now it's going to have a big fat 90-degree angle, at least one. So with that in mind, let's talk about the properties of rectangles and let's practice with those. Okay, so for practice, here is our problem. Make sure that you're writing these properties down. I think that will be really helpful, especially that flow chart I showed you where it's parallelograms, rectangles, so that you can remember these properties. So with this in mind, let's talk about that. The first one says and in geometry, we never assume anything. We have to either be told it or we have to prove it. And so I'm telling you JKLM is a rectangle. So this box right here is a rectangle. That means we got some 90-degree angles. We have diagonals that are congruent. We have opposite sides that are congruent. So with that information in mind, let's see what we can do here. We can take our, let me grab some pens here. Okay, so LP is this guy right in here, and that is 3x plus 7. 3x plus 7. Then we also know MK is 26. MK is this whole thing along here. So we know this guy all along here is 26. Okay, so with that information in mind, what can we do? Well, we know that these diagonals, not only do they bisect each other, because that's a property of a parallelogram, but they are also congruent. So if this whole thing is 36, then, and I'm sorry, 26, not 36, then that means that this guy plus this guy is also going to be 26. Now, are we explicitly told what that guy is? That this one right here, this PJ. We are not explicitly told what it is. However, because this is 3x plus 7 and it bisects our diagonal, that means this is also 3x by 7 or plus 7. So what we could do there is we could say 3x plus 7 plus 3x plus 7, or we could just say 2 times 3x plus 7. So if we say 2 times 3x plus 7, that's going to give us this whole diagonal because those diagonals are congruent. So that equals 26. From here, let's go ahead and solve this. Now, I could do 2 things. I could distribute that 2 and get 6x plus 14, or I could save a little bit of time and just divide both sides by 2. Divide by 2, that only sometimes works when you have nice pretty numbers here that evenly divide. That's when it works. 3x plus 7 equals half of 26, we get 13. So let's minus 7 from both sides. We end up with 3x equals 6. Let's divide both sides by 3. Divide by 3. And x equals 2. X equals 2. Let's go back, make sure we're answering the right question. And the question isn't written here, but it is to find the value of x. So we have done that. Now let's take a look at this next one. LJ is 4x minus 12. So that's this whole thing here. I think it helps to maybe draw some lines here. So we know LJ, this whole thing right here is 4x equals 12 or minus 12. And then we know km, which is this whole thing here, is 7x minus 3. Now this is different from these guys, so we don't want to use our previous expressions there. So what we're going to do is say, well, if this whole thing is one thing and this whole thing is the other, then we can set them equal to each other. So 4x minus 12 equals 7x minus 36, minus 7x from both sides, minus 7x, cancel, and then we're going to add 12 to both sides at the same time, so plus 12. We end up with negative 3x equals negative 24. Divide both sides by negative 3, and x equals 8. Okay, so we were able to find x for that one as well. Let's talk about the angles now. As we talked about the properties of a parallelogram and the properties of a rectangle, remember those angles are 90 degrees, 90 degrees. Okay, the other important thing is that the diagonals, so when we learned in parallelograms, the properties of parallelograms is, remember, the diagonals bisect each other, right? So that means the diagonals are cut in half. So what we know over here is that these guys are going to be 90 degrees. So if we look at this and we say, all right, let's see, we know MATH, haha, math, is a rectangle. If the measure of angle 1 is 55 degrees. 55 degrees. And let me clarify a little bit on that. The diagonals bisect each other, not the angles. I shouldn't have said it that way. I was looking at the diagonals and thinking the diagonals bisect each other, but they don't bisect the angles. So, and we're talking about angles for this one. I got really excited about the diagonals. So the diagonals don't bisect the angles, they just bisect each other. So we do, and we don't know that these create 90-degree angles on the inside. We do know that these are created 90-degree angles here, but we don't know that those guys are going to be cut in half. So I misspoke on that. But since we know that that is 55 degrees, well, what we know here is that these guys, these diagonals, not only bisect each other, that part is important because it means this guy is congruent to this. But because those diagonals are also congruent, then this is also congruent to this. So if we take this triangle here and we say that's a P for the point here. So we take that triangle and it looks like this, and we have MPH, MPH, and we know that this is 55 degrees. And then we know this is congruent to this. That is an isosceles triangle. And remember, in an isosceles triangle, if you have two sides of the triangle that are the same, the angles opposite those sides are also the same. So what we have to do here is, we know that we have 180 degrees in a triangle, 180 degrees in a triangle. So if we take 180 and we minus that 55, that 55 degrees right there, minus 55, that leaves us with 125. So these two angles here, when added together, are going to be 125. But because this is an isosceles triangle, those angles are equal to each other. So all we have to do is take 125 and divide that by 2. And if we do that, we end up with 62.5 degrees. So we now know that angle 2 is 62.5 degrees. Hopefully this helped you better understand your rectangles and your the properties of rectangles. We'll see you next time.